The story of computers begins long before silicon chips and the internet. It is a tale that stretches back through the annals of history, to a time when humans first sought to understand and manipulate the world around them through the power of numbers. It starts with a fundamental human desire to calculate, to process information, to make sense of the world through numbers. This desire is as old as civilization itself, manifesting in the earliest tools and methods devised by our ancestors. From the abacus to the astrolabe, humans have always sought tools to aid their computational endeavors. The abacus, one of the earliest known calculating devices, allowed for basic arithmetic operations and was used by various ancient civilizations, including the Sumerians, Egyptians, and Chinese. These early inventions, while rudimentary, planted the seeds for the digital revolution to come. The astrolabe, another ancient tool, was used by astronomers and navigators to measure the altitude of stars and planets, demonstrating the human drive to understand the cosmos through calculation. The true forefathers of the computer were mathematicians and logicians who dared to imagine machines capable of complex calculations. These visionaries laid the theoretical foundations for the computational devices that would eventually transform our world. Charles Babbage, a 19th century English mathematician, envisioned a mechanical analytical engine that could be programmed to perform a variety of computations. His design included many features found in modern computers, such as a central processing unit and memory. Ada Lovelace, a brilliant mathematician and collaborator with Babbage, is considered by many to be the first computer programmer, having written theoretical programs for the analytical engine. Her insights into the potential of such a machine went beyond mere calculation, envisioning a future where computers could create music, art, and more. These early pioneers, though limited by the technology of their time, laid the conceptual groundwork for the computers we know today. Their work was constrained by the mechanical and steam-powered technology available in the 19th century, but their ideas were far ahead of their time. Their ideas, born in an era of steam engines and mechanical gears, would eventually blossom in the digital age, transforming the world in ways they could scarcely have imagined. The Industrial Revolution provided the technological advancements that would later be crucial in the development of electronic computers. The quest for a thinking machine had begun. This quest would lead to the development of early electronic computers in the 20th century, such as the ENIAC and the Colossus, which were used during World War II for code breaking and ballistic calculations. These machines were the precursors to the modern computers that have become an integral part of our daily lives. The ENIAC, one of the first electronic general-purpose computers, was a massive machine that filled an entire room and used thousands of vacuum tubes. Despite its size and complexity, it represented a significant leap forward in computing technology. The development of these early computers was a collaborative effort involving many brilliant minds, including a number of pioneering women who played crucial roles in programming and operating these machines. Their contributions laid the groundwork for the diverse and inclusive field of computer science we see today. As technology advanced, computers became smaller, faster, and more powerful. The invention of the microchip in the mid-20th century revolutionized computing, making it possible to create compact and efficient machines that could be used in a wide range of applications. Today, computers are ubiquitous, found in everything from smartphones and laptops to cars and household appliances. The digital age has transformed every aspect of our lives, from how we communicate and work to how we entertain ourselves and explore the world. As we look to the future, the quest for ever more powerful and intelligent machines continues. Advances in artificial intelligence and quantum computing promise to push the boundaries of what is possible, opening up new frontiers in science, technology, and beyond. The dawn of the digital age is just the beginning of an incredible journey. The mid-20th century witnessed a confluence of wartime needs and technological breakthroughs that propelled computing forward. This era was marked by an unprecedented urgency to solve complex problems, driven by the global conflict that was World War II. The necessity to process vast amounts of data quickly and accurately led to innovations that would forever change the landscape of technology. World War II, with its demands for complex calculations for ballistics and code breaking, spurred rapid innovation in electronics and computing. The war effort required precise calculations for artillery trajectories, cryptographic analysis and logistics, pushing the boundaries of what was technically possible at the time. Engineers and scientists were tasked with creating machines that could handle these immense computational challenges. Out of this crucible emerged the first generation of electronic computers. These early machines were monumental in size and ambition, representing the cutting edge of technology in the 1940s. They were the precursors to the modern computers we rely on today, laying the groundwork for future advancements. One such marvel was ENIAC, Electronic Numerical Integrator and Computer, a behemoth of a machine completed in 1945. ENIAC was a groundbreaking achievement designed to calculate artillery firing tables for the United States Army. It was capable of performing thousands of calculations per second, a feat that was previously unimaginable. Occupying a large room and consisting of thousands of vacuum tubes, ENIAC could perform calculations at speeds previously unimaginable. The machine's sheer size and complexity were a testament to the ingenuity and determination of its creators. Each vacuum tube acted as a switch, and the machine's ability to perform rapid calculations was a significant leap forward in computing technology. It marked a turning point, proving that large-scale electronic computation was possible. ENIAC's success demonstrated the potential of electronic computers to handle complex tasks, paving the way for future developments in the field. This breakthrough was a crucial step in the evolution of computing, showing that machines could be built to process information at unprecedented speeds. Another pioneering machine was the Manchester Baby, built in England in 1948. The Manchester Baby, also known as the Small-Scale Experimental Machine, SSEM, was a significant milestone in the history of computing. It was designed to test the feasibility of the stored program concept, which would become a fundamental principle of modern computers. This smaller machine was the first to store both program instructions and data in its electronic memory, a key concept known as the stored program computer. This innovation allowed the machine to be reprogrammed without altering its physical structure, making it far more versatile and efficient than its predecessors. This innovation paved the way for more flexible and programmable machines. The ability to store and execute instructions electronically meant that computers could be used for a wider range of applications, from scientific research to business data processing. This flexibility was a game changer, opening up new possibilities for the use of computers in various fields. The pioneers of this era, often working in secret government labs, were driven by a shared vision to create machines that could not only calculate but also process information, store it, and act upon it. These visionaries, including figures like Alan Turing and John von Neumann, laid the theoretical and practical foundations for modern computing. Their work was often shrouded in secrecy due to its military applications, but their contributions were invaluable. Their work laid the foundation for the information age. The innovations and breakthroughs achieved by these early pioneers set the stage for the rapid development of computer technology in the latter half of the 20th century. Their legacy is evident in the powerful, versatile machines we use today, which owe their existence to the groundbreaking efforts of these early computing pioneers. The first generation of computers, spanning from the 1940s to the mid-1950s, was defined by the use of vacuum tubes as the primary electronic component. These early machines were the pioneers of the digital age, laying the groundwork for the technological advancements that would follow. These bulky, fragile, and power-hungry tubes acted as switches and amplifiers, enabling the flow of electrical signals that represented data. Each vacuum tube was a marvel of engineering for its time, but it came with significant drawbacks. The tubes generated a lot of heat, which often led to frequent failures and the need for constant maintenance. While revolutionary, these early computers were limited by their size, cost, and reliability. They occupied entire rooms and required extensive cooling systems to prevent overheating. The cost of building and maintaining these machines was astronomical, making them accessible only to large organizations and government agencies. Programming these early machines was a laborious task, often involving the physical manipulation of wires and switches. Engineers and programmers had to manually set up the machine for each new task, a process that could take days or even weeks. This method of programming was not only time-consuming but also prone to errors. Input and output were primarily in the form of punched cards and paper tape. These methods were slow and cumbersome, but they were the best available at the time. Punched cards and paper tape allowed for the storage and retrieval of data, albeit in a very limited and inefficient manner. Despite these limitations, first-generation computers found applications in scientific research, military applications, and data processing for large organizations. They were used to perform complex calculations that were previously impossible or took an impractical amount of time to complete by hand. The UNIVAC-1 Universal Automatic Computer, introduced in 1951, marked a significant step forward. It was one of the first computers to be designed for business and administrative use, rather than purely scientific or military applications. It was the first commercially successful computer and gained notoriety for predicting the outcome of the 1952 US presidential election. This event captured the public's imagination and demonstrated the practical potential of computers in everyday life. This event demonstrated the potential of computers to process vast amounts of data and provide insights into complex problems. The ability to quickly analyze and interpret data opened up new possibilities in fields ranging from economics to meteorology. The era of vacuum tube computers, though short-lived, proved that electronic computation was not only possible but also held immense promise. These early machines laid the foundation for the development of more advanced technologies, leading to the rapid evolution of computers in the decades that followed. The lessons learned from the first generation of computers continue to influence modern computing, reminding us of the incredible journey from vacuum tubes to the sophisticated devices we use today.